What I'd like to do in this video is introduce you to some supplemental tables that I've posted on Learning Suite. You can find them under the file that is titled Supplemental Timber Tables. It's a PDF that I've posted there. There's 4 different tables on here. 3 of them have to do with adjustments for strength, and then the 4th table in that particular file has to do with connections with nels. And we'll actually go through that in another video here in just a handful of minutes. The first table that shows up in this particular file is the different types of adjustments that actually exist. I'm not going to test you on this table specifically. This is more just for your information. But what you'll notice here is that there's a whole bunch of different adjustments that you have to make when we're dealing with sawn lumber. And we've already been introduced to load duration. I think that's figure 9.23 in your textbook. The textbook introduced you to moisture and temperature and size and said those are all equal to 1 for the sake of this class. We'll continue to not go through moisture and temperature, but we will look at size in one of the other tables here in just a few minutes. We've also been introduced to column stability, and but what you'll notice there is there's a handful of other adjustment factors that we haven't been introduced to. So for example, if you're dealing with looking at bending stress, allowable bending stress, capital F sub B, then you would need to utilize all of these different adjustments in your calculations to accurately assess the true strength of that particular that particular beam that you're looking for dealing with bending. And again, duration and size we will deal with. Column stability we will also deal with when we're dealing with columns. You'll notice that column stability only shows up when we're talking about compressive stress, like we did last time, compressive stress of a column. I do want to quickly note repetitive member. It's kind of an interesting one. Repetitive member is a particular adjustment that exists for horizontal members. So we're talking about rafters or joists, something that's supporting a deck or a roof. And what this particular factor does is allows for an increase if you get enough of these members close enough together. There's kind of a Sunday school lesson in that. When you get a bunch of people close together, they tend to strengthen each other. You get a bunch of floor joists together, they also have a strengthening effect. And so you've got to have at least 3 in number. They've got to be not any further apart than 24 inches on center. And if you do that, what it allows you to do is make an adjustment of 15% increase or 1.15 as an adjustment factor for the strength related to the members that are repetitious there. So again, just noting that all these different parameters exist, and that so it's a little more complicated than what we're going through in this class. If we were taking a full-blown timber design course, we would actually go through each one of these and make sure that you knew how to do that. The second table that we want to introduce you to is the table that actually gives you the baseline values. For example, if you want to find what the allowable bending stress is without the adjustments included so far, and that's why I call it the baseline value, then we would use this column right here for bending stress. Now notice that this particular table is specific to Douglas fir larch. If you go back to table 5.2 in your textbook, there's 3 different species that exist, and each of those species has a number of different grades. What you would find is you'd actually have to have a different table for each one of the different species. Again, this one's specific to Douglas fir larch. I'm not going to give you lots of different design tables. We'll just go ahead and we'll use this one. So we'll assume from now on that we're going to use Douglas fir larch as our choice of species because this is the table that we would want to use. But no, in the real world, you'd actually have to find the specific table for your species. Next thing we do is we break it down into the different classifications. So we've got dimension lumber, we've got beams and stringers, that's the horizontal elements, and we've also got posts and timber. Those are the larger vertical elements. So these tend to be beams, generically speaking, and these tend to be columns, generically speaking. Remember that from our previous discussion, these are rectangular in nature, cross-section that is, and these tend to be square or nearly square. Dimension lumber, if you recall from our previous discussion, was anything that's a 2x, a 3x, or a 4x. Finally, the only other thing you need to note when reading this particular table is what particular grade we're dealing with. So we're dealing with dimension lumber. I would call out a specific grade, maybe stud grade, maybe a number 1 grade, maybe number 1 and better grade. Note that I will use the specific wording that is in here so you would quickly know what I'm asking for. And as an example, then if I was to give you a 2x4 that was stud grade and we were looking for the adjustment for bending stress, then we would come to the dimension lumber category. Right here we would find stud grade, and we know we want bending stress, and we follow those values across, and it tells us that our baseline allowable bending stress is 700 psi. Note that all the values in this table are measured in psi. Reading the table isn't too terribly complicated. It gives us the value that we're going to start with before we use our adjustments. So we'll use this table both in the examples and the homework problems. You'll also need to be able to grab values from this table for multiple choice tests. So if you know how to read the table, pull a value off, pretty straightforward. Table number 3 is the table that we want to use for the size adjustments. 2 major breakdowns in this table. The first one, you'll notice that they call this C sub F, F for size. I'm not sure silent F in the word size there, but the size adjustment factors. And there's this intersection right here that deals with bending stress. And there's this outer section here that deals with compressive stress. So if we're dealing with beam bending, we'll use that intersection. If we're dealing with compressive stress or columns, we'll use that outer section. All right, just erase those so we unclutter the chart just a little bit here. The next major breakdown is the grade. And you'll see that there's a top section right here that has to do with most of the grades, everything except stud grade. And then the bottom section right here, which is specific to stud grade. All right, so the next element that we would want to be able to do is figure out how to pull a value off of this. So let's first off deal with bending stress. So this intersection right here for bending stress. If I'm dealing with a 2x, a 3x, or a 4x, note that this table is specific to the dimension lumber. I failed to mention that. If we have something that's a beam or stringer or a posts and timber, we'd actually have to go with another table. So we'll just give you one table to deal with. Make this adjustment only for dimension lumber. That's where it matters the most. And so I like to give this table here. A 2x, a 3x, or a 4x anything is the way we read this chart. So if I'm dealing with a 2x4, we've got 2 inches by 4 inches, and my adjustment factor would be 1.5. Let's go ahead and erase those off there. If I'm dealing with a 4x8, a 4x8, oh, by the way, this would be for anything but stud grade. I failed to mention that. So 4x8, anything but stud grade, then our adjustment factor is 1.3. And that's what we would multiply into the equation for allowable bending stress. Let's say we're dealing with a 4x6 that is stud grade. 4x6 that is stud grade, adjustment factor is actually 1.0, no adjustment at all. When we're dealing with compressive stress, out here, you'll notice that we don't have the distinction between 2x and 3x and 4x anymore. So everything is a 2 by, 3 by, or 4 by. And again, same breakdown on stud grade or everything else. If I've got a 2 by 8, then the adjustment factor is 1.05, assuming that I'm not a stud grade. If I'm dealing with a 2 by 4 that is stud grade, then we would follow the same logic through. This time we would do 2 by 4 that's stud grade, and my adjustment factor would also be 1.05. So these are the values that we will use in the adjustments. Table 4 we're going to skip for now. I'm going to come back to it when we do the nailing or connections for timber here in a different video.